Hello friends, welcome back. In this video, we are going to understand one of the most critical concepts in statistics as well as in Six Sigma, and that is p-value. We are going to understand this p-value with the help of practical example. That means how to calculate the p-value, how to interpret the p-value, what is the caution that we need to take while interpretation of the p-value, and what is the entire procedure to conduct the hypothesis testing. Before to understand the p-value, we must know some of the basic concepts from hypothesis testing. So we are going to start with the basic terms in hypothesis testing. If you want to know these basic concepts, then I had already made a video on it, that is hypothesis testing all concepts. So in this video, you are going to learn what is meant by the test statistics and significance level, what is meant by the critical value, what are the null hypothesis, what is the alternative hypothesis, and what are the different types of alternative hypothesis like one-sided alternative hypothesis, two-sided alternative hypothesis, and you also need to understand what is meant by the type 1 and type 2 errors. If you are aware about all these terms, then it's absolutely fine. But if you don't know what are these terms, then before to understand the p-value, please visit this video. I had given the link of this video into the description. After understanding these basic concepts from the hypothesis testing, then we need to understand what is meant by the p-value. What is p-value? P-value is nothing but the value of probability. And what is that probability value? Probability value that tells you how likely it is that your data could have occurred under the null hypothesis. That means we are going to understand what is the evidence supporting to the null hypothesis. You will get more idea about it and more clarity about it once we go for the example of it. And this p-value always indicating support to the null hypothesis. That means if the p-value is low, then we are going to reject the null hypothesis. And when we are having the p-value on higher side, then there is insufficient evidence to reject the null hypothesis. That means at any point of time, we are talking about what is the evidence that is supporting to the null hypothesis. After understanding the meaning of p-value, let's understand how to calculate the p-value. So you will also get the more clarity about it. P-value is calculated by using the sampling distribution of test statistics. That means for every statistical distribution, we are having the different formula to calculate this test statistics. While calculation of this p-value, we need to consider three things. The first one is what is null hypothesis, what is the sample data, and third one is what is the type of test being done. What is meant by type of test being done? Type of test being done means we are having the three types of tests and we need to select the different formulas while calculation of this p-value. There can be the lower tail test and there can be the upper tail test. This is also called as left tail test and right tail test, and both of these tests are also called as one tail test. In addition to that, we are having again another type of test that is called as a two-sided or both tail test. For the lower tail test, p-value is calculated as probability of test statistics which is calculated from the data, and to calculate that we can also use the Excel as well as Minitab to identify what is a cumulative distribution function for that particular observed value of test statistics. Here in this equation we can say P is nothing but the probability of an event. This is also called as a p-value. TS, capital TS is nothing but the test statistics or critical value. This is calculated directly from the distribution function. Small ts is the observed value of the test statistics which is calculated from the data that we have collected, or we can say that is calculated from the sample. And the CDF, that is nothing but the cumulative distribution function of the distribution of the test statistics under the null hypothesis. We are going to take the example for each of these tests and you will get the more clarity of it after the example. For the upper tail test, the p-value can be calculated as p-value is equal to the probability of test statistics or the critical value which is greater than or equal to the test statistics which is calculated from the data when null hypothesis is true. And this is calculated as 1 minus cumulative distribution function of the test statistics calculated from the data. And for the two-sided or both tail test, this p-value is calculated as 2 into probability of test statistics or the critical value which is greater than or equal to the test statistics which is calculated from the data when the null hypothesis is true, and that is equal to 2 into 1 minus cumulative distribution function of the test statistics which is calculated from the data. We are going to understand how to calculate the p-value for each type of test with the help of example. Okay, so let's take an example. We are going to take the three examples. The first example for calculating the p-value for lower tail test, then calculating the p-value for the upper tail test, and we are also going to take the example for calculating the p-value for two-sided tail test. This is the first example of calculating the lower tail p-value. Suppose you conduct a one sample lower tail z test and the resulting value of the statistics calculated from the data is minus 1.785. In our formula it is a smaller ts. That means smaller ts is equal to minus 1.785. Now you want to calculate the p-value for the z test. Let's see the procedure to calculate the p-value into the Minitab first, and then I will explain how to calculate that into Microsoft Excel. To calculate the p-value for this normal distribution of one tail z test, we can go to the calculator, then select the option of probability distribution and then select the normal distribution. After selection of this normal, then we need to enter the value for input constant. Here we need to mention the value of minus 1.785, for which we are going to calculate this p-value. Then we can mention it as an optional storage, so we can call it as a K1, let's say, and then click OK. To see what is the p-value, then go to the data and click on the display data option. Click on the K1 and click OK. So here you will get what is the p-value. The p-value is equal to 0.0371307. We can also use the Microsoft Excel to calculate this p-value. Here we can say we are having the normal distribution, lower tail test, and the lower TS, that means the observed value of the test statistics which is calculated from the sample data, which is equal to minus 1.785. As we are going to calculate the cumulative distribution function for normal distribution, then we need to use this formula, normal distribution, that means is equal to norm dot distribution. Then we need to put this value of C3, which is equal to minus 1.785. Then we need to put what is the mean and standard deviation for the standard normal, which is equal to 0 and 1, and make it as a final, that means cumulative distribution, which is equal to true, and put the enter. So after enter, we can get the p-value, which is equal to 0.037131. So this is exactly same as that we have calculated from the Minitab. As we had seen, p-value is nothing but the evidence that we are going to support the null hypothesis. Here, depending on the significance level, if it is 0.05, then we are going to reject the null hypothesis because p-value is less than 0.05. We are going into the detail of this interpretation of this p-value later. Now let's take another example for calculation of the p-value for upper tail test. This is the second example of calculating an upper tail p-value, and the resulting value of the statistics calculated from the data is 1.785. This is positive. So the smaller TS, which is equal to 1.785. Now you want to calculate the p-value for the Z test. Now let's calculate this p-value in Minitab first and then into the Excel. Before to calculate the p-value of the upper tail test into the Minitab, we need to understand the property of the normal distribution. The normal distribution is exactly similar if we cut that distribution into the middle. That means lower part of the distribution is exactly same as that of the upper part or right part of the distribution. And the overall area under the curve is equal to 1. That means 100%. Now let's go to the Minitab to calculation of the p-value for upper tail test. Go to the calculator, probability distribution, then go to the normal distribution. Here we need to calculate the probability for constant, which is equal to 1.785. So we need to change this value to 1.785 and we need to make it as a K2. Now if we come back to the property of the normal distribution, we are interested into the probability on the right side, right? So whatever the probability that we are getting, we need to minus it from the 1 because the entire area under the curve, which is equal to 1. So the p-value that we are going to calculate, that will be 1 minus this value. Okay. So go to the Minitab calculator, click on calculator. Here store the resulting variable, we can call it as a k3 and we can call it as an expression of 1 minus k2. That is the p-value or the probability onto the left tail test. Click OK and then we will getting the value for the k3. Just go to the data and click on display data, select k3 and click OK. So you will be getting this probability again, which is equal to 0.0371307. This is exactly similar to the left tail probability. This is because the normal distribution is symmetric. Now, if you want to calculate that into the Excel, we can use the same formula. It's a normal distribution, it's an upper tail test, and we are going to calculate the p-value for this TS. That's the test statistic, which is equal to 1.785. The formula is equal to 1 minus here, right? 1 minus normal distribution of, we need to take this 1.785, 0 and 1. These are the mean and standard deviation for the standard normal, and true for the cumulative distribution function. If we make it as an enter, then again we can get this same p-value, which is equal to 0.037131. Now, let's take an example for calculation of the two-sided test. We can continue with the same example. Suppose you perform a one sample two-tailed Z test. The resulting test statistics here is 1.785. That means small ts is equal to 1.785. Now you want to calculate a p-value for the Z test. Here we need to remember that this is a two-tailed test. So we need to use the different formula to calculate this p-value. Okay, so let's understand how to calculate that in Minitab first and then how to calculate that into the Excel. To calculate the probability distribution, go to the calculator, probability distribution, then normal, and again we need to select the value for either minus 1.785. Let's select minus 1.785 and mark it as a K4 now and click OK. Here we need to understand that the probability on the left side is again same that of the probability on the right side. Okay, so if you are looking for the two-tailed test, then we need to simply add the probability on both sides, or we can say we can calculate the probability on one side and then we can multiply it by 2. So to calculate the final probability, we can go to the calculator, use the function calculator. We can say it is a K5 and that is nothing but equal to 2 into, we can say it is a K4 and then click OK. So to identify what is the final probability, we can go to the data and select display data. Select as a K5 and click OK. So you'll be getting this probability on the two-tailed test. This is nothing but the p-value, which is coming as 0.0742613. Now let's see how to calculate in Excel. In Excel, we can say this is normal distribution, two-tailed test. The value that we are going to calculate on the one side, which is equal to minus 1.785, and the p-value is nothing but which is equal to 2 into normal distribution of this one-sided value, which is equal to minus 1.785, 0 and 1 for the mean and standard deviation for the standard normal, and true for the cumulative distribution function. If we put the enter, then we can get this p-value as 0.074261. This is exactly same as that we have calculated from the Minitab. Now the next part is, though we have seen how to calculate the p-value, we need to take a caution while using this p-value. We need to understand that the p-value can only tell you whether or not the null hypothesis is supported. It cannot tell you whether your alternative hypothesis is true or not. So this is purely the evidence to support the null hypothesis. If your p-value is low, then we can reject the null hypothesis. If your p-value is high, then we can say that there is insufficient evidence to reject the null hypothesis. And the second thing, we should have appropriate sample size so that we can calculate the correct p-value. Smaller sample size can lead to the wrong conclusion about rejection or supporting the null hypothesis. So up to this point, we had seen what are the basic terms in hypothesis testing, what is p-value, how to calculate the p-value, what are the different formulas we need to select depending on the different types of test statistics, and what is the caution that we need to take while conducting or interpreting the p-value. Now let's understand this entire procedure with the help of one example, so you will have the complete clarity about this p-value. Up to this stage, we had seen the one sample z test for calculation of the p-value. So let's continue the same test with another example to understand the entire procedure to calculate this p-value. An electronic circuit has an average response time of 5 milliseconds with a standard deviation of 0.25. The design team has made some improvements to the circuit. After improvement, 16 samples were tested in a lab. The average response time of 16 assemblies was found to be 4.88 milliseconds. Now, can the team claim with 95% confidence that the response time is significantly reduced? Okay, now if we look at the given data in this example, we can see here mu0, that is mean, is equal to 5, sigma, that is equal to standard deviation, which is 0.25, n, which is equal to 16, that is nothing but the sample size. In this example, the null hypothesis is h0 colon mu is equal to 5. This is a historical average, and alternative hypothesis is that we want to prove h1 colon mu is less than 5. As we are interested in mu is less than 5, this is a one-tailed test with alpha is equal to 0.05 distributed on the left tail. Okay, so why it is a left tail? Because we are interested in less than. And why the value of alpha is 0.05? Because this is a significance level, that is nothing but the 1 minus this confidence level. So 1 minus 0.95, that is coming at 0.05. Therefore, let's calculate what is a p-value in this example, and depending on that p-value, what is our interpretation. Here we can see the sample average x bar, which is coming as 4.88 milliseconds. Now, if you are taking an example for the one sample z test, then we need to use the formula for calculation of test statistics, which is equal to z is equal to x bar minus mu0 divided by sigma upon root n. Here, please note that the formula for calculation of the test statistics is different for every statistical distribution. For the one sample z test, this is the formula. If you put the value of x bar, mu0, sigma and root n, then we will get the test statistics as minus 1.92. This is the test statistics calculated from the data. We had seen this is a left tail test with significance level of 0.05. Now, we need to calculate the test statistics, which is called as a critical value, that we can calculate from the cumulative distribution function. So here we can select the standard normal distribution table, and we can identify what is the z score associated with this significance level. If we go to the 0.05, which is coming as here, okay, so the value coming as 1.6, and it is somewhere between 0.4 and 0.5. So we are getting the value as 1.645, right? Now, if we look at here, the calculated z statistics minus 1.92 is beyond the critical value. Thus, we can say as the calculated z statistics is minus 1.92, this is beyond the critical value and this is in the critical region, so we should reject the null hypothesis. If you look at this distribution plot for this normal distribution, we can say that z critical is coming as minus 1.645 and the z calculated is going beyond this z critical. So we are going to reject the null hypothesis because this value is going into the area of rejection. This is the one way either to support the null hypothesis or reject the null hypothesis, and the second way is the calculation of the p-value. So let's calculate the p-value for this example. Let's calculate the p-value of this example in Minitab first and then into the Microsoft Excel. So go to the calculator, probability distribution, select the distribution as normal. Input constant here we need to select as minus 1.92 and we can call it as a K6 and we can click on OK. Go to the data and display data, click on K6, click OK. So you will be getting the p-value here. The p-value is getting as 0.0274289. Okay. Now if you look at the significance level in our example, this is 0.05. Alpha is equal to 0.05. And if you compare here with respect to the p-value, our p-value 0.027, which is less than alpha. So we are going to reject the null hypothesis. Okay, so let's calculate the p-value into the Microsoft Excel now. This is a normal distribution, lower tail test. The TS, that is a test statistics, which is calculated from the data, is minus 1.92, and we can use the formula for normal distribution. Here the p-value is equal to normal distribution C6, that means the value of the test statistics, 0 and 1, that is for the standard normal distribution, and then calculate what is the cumulative distribution function. If we put the enter here, then we can get the p-value at 0.027429. This is exactly the same as that we are getting from the Minitab. Now we can also use the standard normal table to calculate this probability. So how to do that? We can go to the standard normal table and we can go for the minus 1.92 here. And again we are getting the same value, which is 0.0274. So there are multiple ways to calculate the p-value. Okay, so once we calculate this p-value, then we need to compare this p-value with respect to the significance level. In this example, our p-value is 0.0274. Our alpha is 0.05. So we are going to reject the null hypothesis. There is another simple way to calculate in Minitab, that we can directly use the distribution plot option. So we can go to the graph, probability distribution plot. Then we can select what is the probability, click OK. Then we can select what is the distribution that we are looking for. It's a normal distribution. We can put as a mean as 0 and standard deviation as 1, because this is for the standard normal distribution. Go to the shaded area and insert here the value of the test statistics, which is calculated from the data, so that we can calculate what is the p-value. Put the calculated test statistics here, which is minus 1.92, and then select it as a left tail and click OK. So you will be getting this distribution. So we can say that at the minus 1.92, that's a calculated test statistics, we are getting the p-value as 0.02743. So this is again exactly same as that we are getting into the Minitab, Excel, as well as the standard normal table. So these are the multiple ways by which we can calculate the p-value. This is all about the p-value, and I'm sure that you have got the complete clarity about what is meant by the p-value, how to calculate it, and how to interpret this p-value. If you have liked this video, please don't forget to press the like button, put your valuable comments, and please don't forget to subscribe the channel. At the end of this video, if you want to learn the Lean Six Sigma in most effective and practical way, then please visit at vijaysabe.co/join and vijaysabe.co/training. Thank you for watching and see you in the next video.